Hello, this is Bart Huyskens from E2Create in Belgium, and I've been searching the internet a long time for a good code to do bidirectional full duplex communication between an app inventor and an Arduino, and I did not find anything that fit my purpose, so I started developing on my own. Let me just demonstrate. Let me just demonstrate here how this works. This is my app. This is an Arduino board. This is a Brainbox AVR. It's a really great board to do developments. It's a rugged Arduino Leonardo board with extra power outputs with connectors that it can connect directly to an HC06 Bluetooth device. You can screw connectors to it. It has a lot of power options, so I like to use it to develop new stuff. It's pretty popular in Flemish education here. And this is a normal low-cost I2C LCD 4x20 that I use to visualize some data. Now, if we look at the app, and it's already running for an hour, I think, or so, so it's still pretty stable. If you look at the app itself, then you see that it has two slide bars here, and these two slide bars are used to determine which data needs to be sent from the app to the microcontroller. And the microcontroller, in its case, sends three variables back here, and these are visualized here, visualized the real numbers here, and also I like to visualize this with rulers that, and the position of the ruler determines which number I receive. The numbers that I send here, try to film it correctly, here also are visualized on the LCD here. So works all nicely and neat. Let me just show you what the principle is of my communication. So the app sends data, in this case really fast, actually every 100 milliseconds it sends data from the two rulers that we have here to the microcontroller, and it does it in ASCII format. So these aren't real numbers, these are all ASCII characters that are sent. And it's an L double point and then a few characters that visualize the data that is sent, but it's all characters. Then a semicolon, an R double point, and then the data that is from the second ruler here, the second potentiometer, and then again a semicolon to end the data. This is received by the Bluetooth device, the HC06 low-cost Bluetooth device that connects directly to the Brainbox AVR. This is received here and is decoded in a microcontroller. And the microcontroller at its time, it sends data to, and it are three random, you can put any data in it, but for this demo I use three random numbers that I sent a number between 0 and 100, 0 and 255, and 0 and 1024 that I sent back to the Android device, and all these numbers are divided by an OR sign. It's a vertical line that's somewhere in the left top of your keyboard normally. And this divided, and this sign is used by Appinventor to split this string into parts. So this is the principle that I use to connect Appinventor with the Arduino board actually. Um, Something that I need to say about timing here: if you send, if this data is sent, for instance, every 100 milliseconds, then the Arduino needs to read data every 50 milliseconds, and then um, uh, the data that the Arduino can send back to the Android device can not be sent any faster than with 200 millisecond delays. So 2 times slower than the sending for the Arduino to be for the Appinventor app for Android device to be ready to receive new data. This is all yeah, experience. So maybe you know of different ways, but this works for me, and this is the first app that I get and keep working for a long time, and that keeps stable. So hopefully it will help you. So let us first have a look at the Appinventor code. If you've not worked with Appinventor before, I really like it. It's it looks like a toy, but it's really amazing how nice apps you can make with it. You'll be amazed. Have a play with it, and you'll be amazed. It's free, and that's maybe is the best thing that it only works for Android phones. But yeah, then again, most people have Android phones or Android devices, and it works really nice. These are two buttons that are used to connect to the Bluetooth device in the beginning. This is the data that I put down or determined with two sliders, and these sliders can only give values between 0 and 255, and this value also comes here, and this is the received data that is coming into these three text boxes, labels it's called here, and it's also visualized. It's something that I like to do with a ruler, with a slide bar. So the position of the slide bar will visualize the value of the data here, but it's just playing around with the data. You need to put the Bluetooth client here, and this clock is very important. This clock determines how fast data is sent and is received. This clock, I've put it here at 100 milliseconds, so that's pretty fast. If you don't need the speed, please put it at 1000 milliseconds or something like that. But I want to drive a car with it, so this is pretty fast even for the car. 100 milliseconds. These 100 milliseconds, I'll come back to it. It needs to be identical to the timing variable in Arduino IDE code. So if I go to the blocks screen, then we'll see that these 4 blocks are used to connect to the Bluetooth device. Just look into the code. It's pretty straightforward. Something happens when the screen initializes. Something you need to pick the right Bluetooth device. You need to connect the Bluetooth device in your on your smartphone before you open the app. And you can connect it with this code. You can disconnect it with this code. So it's pretty obvious, pretty straightforward. I have created 2 variables, but Appinventor is really tolerant about variables. It's a variable is as big as you want it. There's no limitations actually. This is a global variable that I use to read data, and I fill it with nothing here. It's the input variable, and this is a list. A list is variables put under each other, all of them. Kind of an array, you could call it. So this is all the data after each other, and this all the received data after each other is coming in this variable, and this is split data in parts, and it becomes a list. We'll look into this a bit further. So when the clock, so every 100 milliseconds we have put the clock to, the timer fires, and it executes this code, and this is actually the only code in this program, and it checks if the Bluetooth client is connected, because if we start sending data to the microcontroller without a connection, then the app crashes. So we first check if the connection is established. If the connection is established, then we send the L double point, and then we take the slider position and format it as a decimal number with no numbers behind the comma, and we add semicolon R double point and again the other slider value, and we end the string with semicolon to end the data. These semicolons are used by the Arduino IDE to determine which data that we want to decode from this string. After sending, the Arduino IDE Appinventor checks if new data is available. If new data is available, then this new data is read into the input variable, and that's the variable that I created here. After that, I use these R signs to split this text in the input variable and put it in a list, and then it's put into a list under each other, and it has an index 1, 2, 3 because we receive these 3 1, 2, 3. We receive 3 bytes. I know this, and all these bytes are separated by these R signs. So let's look back at the app. So if that's split data in the list, then I check if the list consists of 3 different items. If that's not the case, then maybe something has gone wrong with the reception of the data or something like that, and this could make errors or something like that. So we check this, and if it's not 3, we just throw away the data and we wait for next data to come, and that will be better. So I read this data from the global list at index 1, at index 2, and at index 3, and I put it in these 3 variables. And these 3 labels, actually, these are these 3 labels that I put the data in. And at the end, I also, this is the code to visualize the data in these slide bars, in these rulers. And for that, also, because sometimes an item in the list may be empty, I also check if this is not empty. If it's not empty, I put it the thumb position of the slider in this position. And it works fine, it works stable, it has no errors over a long period of time. So this is the code that I have. Yeah, this is also a bit of code to also visualize the position of these 2 rulers here. These 2 sliders is also visualized as an actual number here. So that's the code for that. That's the actual code in Appinventor. And now I'm going to Arduino IDE. And some explanation from me to start with. Libraries I use for the LCD, and this is an important one: timer interrupt Appinventor, timer interval Appinventor at 100. This needs to be exactly the same as the number of the clock here, 100. The timer interval here needs to be exactly the same as the timer interval here, and then the code works neatly together. A few variables that are created, an array that is created, and a string that is created, because I'll explain that later on. some setups to set up the serial ports. The Leonardo actually has two serial ports, and the normal serial port is used for the serial monitor. You see this, the serial monitor that you can use to visualize the data that is incoming, or any data that you send to the serial monitor. And the serial 1.begin, this is the serial 1 is the connection to the HC06 Bluetooth module. Now here in the actual loop of the actual program, I create three random numbers and put it in these three variables, val1, val2, val3, and this is the data that we send later on back to the app. Here you see the delay, and this is an important one. Delay is determined by timer interval Appinventor divided by 2. If this is 100, then this delay is every 50 milliseconds that this delay ends, and that we are going to check for new data that is probably received now. So we send data every 100 milliseconds, and we check for new data every 50 milliseconds to not miss any data. We have experienced that this is the best way to receive data. So if serial available and while serial available, I read this serial data and put it into an array, and every time into the next index of the array, and I add 1, and as long as data is incoming, I put it in the array under each other or after each other as you wish, to be determined later what data is in it. I do nothing with it at this time. So if reading data is finished, I see if it's already time to start sending data. And this is something that I fixed in this way. Maybe you know of a better way, but this was the thing that I or my solution here is I need to the sending of the data to the app needs to be slower than the sending of the app to the microcontroller. So I slowed it down 4 times. Every 4 times I read data, I send data. So this is the number of cycles is bigger or equal to 4, then and here the number of cycles is added every time I read data, every 500 or every 50 milliseconds here. I also do not start sending data before the connection is established. So before any data is received from the app, I do not start sending data, because this also crashes the app. So this is the sending of these 3 values here, and I've put this OR character in between these 3 values. Okay, and then this code is used to decode the incoming data. You know that the incoming data, remember you here, that incoming data was of this form: L double point XXX semicolon R double point. So I need to determine where the L is, and then 2 positions after that the actual data that I want, that I'm interested in, is there, and I need to also determine where the R is, and 2 places behind that the R the actual data is. And the actual data is always ended with a semicolon. That's also important to know, and that's the thing that I use here in my code, because I search for the L here. I first I copy the actual in serial array. This I copy this one to a string. I make a string of it and I copy it into a string, because I can't do string manipulations on an array. I can't do it. Maybe you can, but I can't. So the L is the place of the L is determined. It's probably place 0 of my in my string, and then this L position plus 2, there is where the actual data that I am interested in starts, plus M, but M is 0 at the first time we run through this loop. So what are we going to do? We are going to do this loop while, so as long as this characters that are determined here are not equal to the semicolon. So I'm going to do this loop until I reach this semicolon here. So what do? The L position plus 2 plus M, that character at that position, I subtract 48 from that. Why is that? That's because the actual code is received as ASCII format, and the ASCII code, ASCII number for 0 is 48, the ASCII number for 1 is 49, so I need to subtract 48 from it, and then I have the actual value of that actual digit. But every digit has a different value in the position it is, so every digit is multiplied by 10. So the actual number is multiplied by 10 if there is another digit available. If you have a look at this code step by step, you'll see how it works. It's maybe a bit difficult to explain right now, but you'll see how it works. And this actually converts the ASCII characters into a real usable number that I need to drive something or put something in the right order. So this rule, this line of code is used, I wrote this to, because sometimes I received corrupt data, a -1 or a 17,000 or something like that, some really strange data. Don't know exactly why it is, but if I use this line of code, I only use data that is between 0 and 255, and I throw away everything else. So if it's between that, it's okay. If it's not between these two values, I use the old value, so the value that I read in 100 milliseconds ago, so that's no problem to use this. Okay, exactly the same code for the R value that I use, and after this it's only visualization of the data. These 4 lines are to visualize the data in the serial monitor. Here, see it like this, and these lines are here to visualize the data on the LCD. So I hope that this helps you out in some way. I'm glad I have it working now. I've been busy with it for a few days, but if anyone can help me out or improve this code or has any questions, don't hesitate to contact me.